Your Honda's owner's manual says 0W20, but there's a technical service bulletin sitting in dealer databases right now that tells a very different story. And Honda didn't exactly advertise it. That bulletin changes everything about this debate. And if you've been defending the factory spec because it's what Honda says to run, I get it. But by the end of this, you're going to want to look up your specific engine before your next oil change. Before anyone says this is just an oil nerd debate, let me show you what choosing the wrong viscosity actually looks like inside an engine that's been running it for 80,000 miles. Picture two Kit 24 engines. Same year, same mileage, both turbocharged Honda CR-Vs. One was maintained on 0W20 full synthetic with 5,000 mile intervals, exactly by the book. The other was running 5W30 with the same intervals. You pull them both apart at 90,000 miles. The 0W20 engine has scoring on the cylinder walls. Not catastrophic, not seized, but visible marks where the oil film thinned under sustained heat. The bearings show accelerated wear. The timing chain tensioner shows stretch. The 5W30 engine looks almost new by comparison. Same driving conditions, same maintenance habits, different oil. Now, is that a universal outcome? No. Is it something that's shown up enough times in teardowns in oil analysis labs that engineers inside Honda's own organization pushed for a change? Yes. And that's where this gets interesting. Honda's reasoning for 0W20 isn't random. It comes from real engineering decisions made under real regulatory pressure, and it's worth understanding before we start pulling it apart. The push toward thinner oils across the industry is largely CAFE-driven, corporate average fuel economy standards. Thinner oil reduces internal engine friction. Less friction means better fuel economy numbers. Better fuel economy numbers mean manufacturers avoid federal penalties and hit their fleet averages. 5% fuel economy on certain platforms. Across millions of vehicles, that matters to compliance calculators. And there's also a legitimate cold start argument. The 0W winter rating means this oil flows almost immediately at startup, even in sub-zero temperatures. The first 10 to 30 seconds after a cold start is when a disproportionate amount of engine wear occurs. Oil hasn't fully circulated, metal surfaces are momentarily dry. A thinner oil that reaches critical components, FAST-DR, has a real engineering benefit there. Honda also points to their own long-term durability testing. They'll tell you 0W20 meets and exceeds ILSAC GF6 standards, that their engines were designed with 0W20 tolerances in mind from the factory, and that switching to a thicker oil in a modern engine could actually increase wear because the clearances aren't designed for it. That's a legitimate argument, and for a lot of driving conditions and engine types, it holds. But here's where things get complicated. Honda issued a technical service bulletin, TSB number 19-083, that quietly expanded acceptable oil viscosity for a specific range of their four-cylinder engines. This wasn't a recall, it wasn't a press release. It was a service document distributed to dealers and technicians, the kind of thing that doesn't make it onto the company's public-facing FAQ. 5-liter turbocharged lineup were experiencing fuel dilution. Gasoline mixing into the engine oil at rates higher than acceptable, particularly in cold climates with short trip driving. And the recommended mitigation? More frequent oil changes, and in some cases, consideration of 5W30 as an alternative viscosity. Read that again. Honda's own documentation acknowledged a viscosity problem severe enough to warrant a bulletin. Now, the TSB doesn't say 0W20 is dangerous. It doesn't say Honda made a mistake, but it does say there are operating conditions where their factory recommendation produces outcomes that require intervention. That's a meaningful admission from an engineering standpoint. To understand why this matters, you need to know what those numbers on the bottle actually mean. And it's simpler than most people make it. The first number with the W, that stands for winter. It describes how the oil behaves at cold temperatures. 0W flows thinner when cold than 5Ws. That's the cold start advantage. The second number, the 20 or the 30, describes viscosity at operating temperature. This is where the real-world protection difference lives. Think of it like this. At operating temperature, around 212 degrees Fahrenheit under normal conditions, higher under load. 20 weight oil is closer to water. 30 weight is closer to light syrup. In a precision machined engine running at normal clearances, 20 weight provides enough film strength under normal conditions. But under thermal stress, extended highway driving in summer, towing, stop-and-go traffic, that builds heat without airflow. That film gets tested. Here's the technical term, HTHS viscosity, high temperature, high shear. This measures how thick the oil remains under the actual conditions happening inside a running engine. Not in a lab at standard temperature, but under the shear forces of pistons and bearings moving at thousands of RPMs, 6 MPAs, 9 MPRs. That gap is not enormous, but in a turbocharged engine generating heat at the bearings and turboshaft, that gap becomes meaningful. Pay attention to this part, because this is what the fuel dilution problem connects to. When gasoline bypasses the piston rings and mixes with your oil, it lowers the effective viscosity of whatever oil is already in the sump. A 0W20 that's absorbed 3% fuel dilution is now behaving like something thinner than 0W20 was to begin with. In a 5W30, that same dilution drops you down toward where 0W20 started. You've still got more protection buffer. In cold climates where short trips prevent the engine from fully heating to boil off that dilution naturally, and the effect compounds over time. Blackstone Labs has processed hundreds of Honda oil samples over the years, and when you look at the wear metal data side by side, a pattern starts to show up that's hard to ignore. 5T Honda engines shows elevated iron and aluminum wear numbers, particularly in samples from cold climates with short trip driving profiles. We're talking iron readings in the 8 to 15 ppm range on some 5,000 miles 0W20 samples, where 5 to 7 ppm is considered normal baseline for this engine family. Their analysts flagged fuel dilution as a contributing factor in multiple sample reports. What does that look like in a real engine? 5T engines, and some technicians have documented this publicly, you'd find varnish deposits around the VTC actuator, carbon buildup on the oil control rings, and in some cases, stretch in the timing chain that exceeds factory spec before 100,000 miles. That's not normal for a modern engine with proper maintenance. Engine builder data from shops that specialize in these platforms tells a similar story. The wear patterns they're seeing on teardowns correlate with extended intervals on 0W20 in thermally stressed applications. Turbos are particularly vulnerable because the turboshaft bearing relies entirely on oil pressure and film strength, and it sees the highest temperatures in the system. Here's where honest people who know engines actually disagree. And it comes down to how you drive, where you live, and what you're asking your engine to do. 0, a quad 4-cylinder from the non-turbo era, fit HRV. The fuel dilution risk is dramatically lower. These engines don't run the same heat and pressure cycle on that oil. The HTHS concern applies less. In these applications, 0W20, full synthetic at 5,000 mile intervals, does exactly what Honda designed it to do. The evidence supports the factory recommendation for this use case. Turbo engines change the equation. 5T in particular, used in the CR-V, Civic Si, Accord, has a documented history with fuel dilution. If you're in a warm climate and you're doing highway miles regularly, the engine gets hot enough to burn off dilution, the turbo operates within normal thermal range, and 0W20 performs adequately. Honda's own data supports this. But if you're in a cold climate, doing a lot of short trips, or you bought the CR-V primarily for local driving without extended highway runs, that's the operating condition the TSB is speaking to. Your engine never fully heats to self-clean. Fuel dilution compounds. Your 0W20 is working thinner than it started. There's also the mileage dimension. Below 60,000 miles on a well-maintained engine with tight rings, fuel dilution is lower because ring seals are still strong. Beyond 80,000, 90,000 miles, ring wear increases blow-by, fuel dilution increases, and the margin you had with 0W20 gets thinner. So here's how to actually think through this for your specific car, because the answer isn't the same for everyone, and anyone who tells you otherwise is oversimplifying. If you're running a naturally aspirated Honda engine, you live in a moderate climate, and you're changing your oil at or before 5,000 mile intervals, stay with 0W20. Honda engineered the clearances for it, the cold start protection is real, and there's no evidence of problems in this application. You're fine. 5-liter turbo, and you're in a cold weather state. Drive mostly short trips under 20 minutes, and you're pushing toward or past 75,000 miles. Seriously consider moving to 5W30. The TSB gives you cover. You're not voiding your warranty by making this switch. You're actually responding to Honda's own acknowledged guidance. 5T, and you're in a cold climate. The minimum move is to cut your interval to 3,500 miles on 0W20. Don't wait for the oil life monitor. The monitor doesn't know your fuel dilution percentage. You do your own math. Here's a physical check you can do right now. Pull your dipstick. Smell it. Gasoline has a very distinct smell. If your oil smells like fuel, even faintly, you've got dilution happening. If it smells burnt or metallic rather than clean oil, you've got thermal breakdown. Both of these are signals your current setup needs adjustment, regardless of what the manual says. Also check the level. Fuel dilution can actually raise your oil level over time as gasoline gets absorbed. If your dipstick reads above the full mark between changes, that's not a good sign. It means you've got contamination in the sump. At your next oil change, bring your used oil to an independent lab. Blackstone, Oil Analyzers, any of the major services, $30. They'll tell you exactly what your wear metals look like, what your fuel dilution percentage is, and whether your current viscosity is serving your engine. One oil analysis pays for itself and avoided repairs many times over. Drop a comment and tell me what you're running. Do a W20, 5W30, or something else entirely, because I genuinely want to know what's actually in people's engines out there. 5T in a cold climate, and I want to hear your experience. Did you switch? Did you notice a difference on the dipstick? If this cleared up any of the confusion around this debate, hit subscribe, because this kind of technical deep dive is exactly what we do here. 5T teardown at 110,000 miles, and the wear patterns tell a story that no spec sheet prepares you for. You won't want to miss that one.